Hey guys, welcome back to Remote Learning Round 2. In today's video, I'm going to be teaching you the fourth index law. So today's learning intention is to learn the fourth index law. The success criteria is to understand the fourth index law and apply it to questions, use knowledge of bases, powers, and multiplication rules to questions, and be able to input powers in a calculator. So we will learn about the fourth index law today, but before we do, we'll just go through a little recap of what I taught you when we were at school. So there are 6 index laws altogether. We learnt the first 3 at school. The first one was, now remember, this is called our base and that is called our power. When you have a base to a certain power multiplied by the same base to a power, and this power can be different to this one here, it could be the same. What happens is you leave the base and you add the powers together. Okay, so I'll show you with an example just in case you're a bit rusty. Let's say, for example, we had v to the power of 2 times v to the power of 5. Okay, so when we multiply 2 bases that are the same, all we need to do to get our final answer is write down that base. So remember, this is our base, that's our power, and we add the powers together. So that becomes v2 plus 5. And our answer is v7. So in order for this first index law to work, the bases need to be the same. The powers can be the same or different, but when there is a multiplication sign between each of these, you add the powers together. Okay? The second index law is the exact same thing, except this time we are dividing. And when you divide the same base by the same or different powers, all you do is leave the base the same and you subtract the powers. So let's do another example. N to the power of 10 divide by n to the power of 6. So because we've got a division sign in the middle, these two things are being divided by each other. So what we do is we take the powers and we subtract them. So it would be 10 minus 6. Okay. And then the answer would be n to the power of 4. Now we did do some questions at school where the division wasn't set out like this. Now remember, this can also be written out in this kind of format. It means the exact same thing. Here you're dividing, here you're dividing. So don't get confused there. Okay? And the third index law is anything to the power of 0 equals 1. Now I'm going to show you 2 examples because these are things that we did go over at school as well. The first one is going to be with brackets. So imagine we had x, okay, squared to the power of 0. Because the 0 is to the power of everything in the brackets, that means that this 0 applies to everything in here, meaning this whole entire thing will equal 1. Okay? Now, what happens if we don't have brackets? Well, if we had a question such as x to the 0, let's say, because the 0 is on this x, our answer would still be 1. But what happens if we had something like this? So let's just remember what the difference is. Because this 0 is now just on this x, that means that the anything to the power of 0 equals 1 rule only applies to this x and this 0, because the 0 is only on top of the x. It is a power of the x. Okay? The 0 is only attached to this x. It has absolutely nothing to do with this 2. Because remember, when there are no gaps between anything, there's an imaginary times sign. So this actually equals 2 times x to the power of 0. See? The 0 has nothing to do with the 2. So that means we would get 2 times, and we know that anything to the power of 0 is 1. So this part here would equal 1. 2 times 1 equals 2. Okay, so that's a recap of the first 3 index laws and what we did at school. Now, today we are going to be learning about the 4th index law. Now, the 4th index law states that when you have a base to a power and that whole entire thing is in brackets to the power of something else, or the same number, the answer is the base staying the same and the power on the base, the power outside the bracket, multiplied by each other. Okay, so you can see all we need to do is take the m as this index over here, the n as the power out here, and we multiply them together. Okay, what this is saying is, remember how I told you before, when you have no gaps between something, there's an imaginary time sign. So this is just making this look neater. Okay, this and this equals the exact same thing. All you need to know is you take these 2 powers and you multiply them by each other. Okay, think about it in a simple way. Take these 2 powers, times them by each other. Even put a little time sign if it's going to help you remember. Okay, so let's try it with some questions. Here, our base is the letter B. Okay, it is to the power of 5 and it is inside brackets, which is to the power of 2. Okay, so what this actually means is B5 is being multiplied by itself 2 times. Okay, so this can actually be written as B5 times B5, because we have B5 here in the brackets and it's being times by itself 2 times. So this is actually the same as this. And what do we know based on our first index law of bases that are multiplied? What happens to their powers? They get added. So really, we can take the long route, use our first index law to answer this question, or we can take the simpler route, which is the 4th index law that I'm teaching you, and know that when you have a base to a power and that's inside brackets to the power of something else, all you do is take these 2 numbers and multiply them by each other. Okay, I'll show you how we get the same answer. So it's this times this, and that ends up being to the power of the base. Okay, and the answer is b to the power of 10. Okay, I proved that it was right. Let's try with the second one using the fourth index law. So what do? We have a base to a power, inside brackets to the power of 3. So all we do is take these two numbers and we multiply them by each other. So our answer is W7 times 3, which equals W to the power of 21. Okay, now let's try some harder questions. Now for this part here, I do have my calculator. You can also use your calculator. Don't feel like you need to do these in your head. If you feel more confident using the calculator, then go ahead. I'm going to show you using the calculator so you can see how I input my numbers and powers in here so that you can do it yourself at home as well. So this time our question's a little bit different because if I cover this 2, this is a question that we've dealt with here and here, okay? But now there's a big number in front of everything in the brackets. So what do? Well, you do the exact same thing. The fourth index law states that this number out here gets put to the power of everything inside the brackets. Okay, so this 4 needs to be multiplied over here, and the 4 needs to be multiplied over here. Okay, now when we have a number or a letter, okay, when we have a number or a letter that is just by itself, it always has a power of 1. All right, we've been through that. So I could actually put an imaginary 1 on top of the 2. Now let's test to see if that's right. So 2 equals 2. 2 to the power of 1 equals 2. It's the exact same thing, okay? So now we can multiply this 4 out here to the power of everything that's on the inside. So we have 2 to the power of 1 times 4, and then U 3 times 4. So I've taken this 4 and multiplied it inside to everything, okay? Everything. Now let's simplify. This equals 2 to the power of 4. What you could do is just simply put 1 times 4 in your calculator to get this answer. Okay? And then for the U, it's 3 times 4, which is 12. So again, all you need to do is put the 3 times 4 in your calculator and you get 12. Okay, so that's our overall answer. Now you could go one step further and get an actual answer for 2 to the power of 4. Let's practice putting that in our calculator. You put 2 and then find your power button. On my calculator, it's the X with a coloured in white box. Click that and then put 4, okay, because it's to the power of 4. You can see that this looks exactly the same as that. Press equals and the answer is 16. So it equals 16 U to the power of 12. Now remember, 2 to the power of 4 is the same as 2 times 2 times 2 times 2. So it's 2 times by itself 4 times. Okay, and remember, this is what we call expanded form. Okay, so let's do our final example before I wrap this video up. This time, we have a similar situation to what happened in example 3, but we have an extra M over here in the middle. What did I tell you about a letter or a number that is by itself with no number as its power? You always put it to the power of 1. Okay, so before I even think about what I'm going to do, I'm going to go ahead and put a 1 on top of the 5 and an 1 on top of the M. Okay? Now my fourth index law states that I multiply whatever's outside to everything inside. So I'm going to take this 2 and multiply it to there, and I'm going to multiply it here, and I'm going to multiply it here. Okay? So let's write that out. 5 to the power of 1 times, because everything is timesing, the 2 that's out here. Then we do the same with the M. So that's M to the power of 1 times it by the 2 that's out there. And then we've got our N to the power of 6. And I'm going to then times that by the 2. Okay, now let's go ahead and simplify these multiplications. Well, 1 times 2 is 2, so this ends up being 5 squared. 1 times 2 again is 2, so M squared. 6 times 2 is 12, so N 12. And there we have our answer. But again, like we did here, we can actually work out what 5 squared is and write an actual numbered answer. So you could use your knowledge of squared numbers and know that 5 squared is the same as 5 times 5, because it's this number times by itself 2 times. Or you can use your calculator. So let's practice doing that again. We put 5 as our big number or our base number. And then on my calculator, it's the X with the white box. And in there, I'm going to put 2. So you can see that it looks exactly the same. Equals, and that's 25. So my answer will be 25 M2 N 12. Okay, I'm just going to show you the index law again. So in case you want to pause me and write this in your exercise book, you can. Okay, and then I'm also going to show you the examples. So you can pause me again here and write these down in your book.